I would like to start from the beginning, because if we wanted to use correctly the total corneal power, we have to understand why IOL power calculation is wrong if after LASIK or PRK or RK if we use standard calculations. So why does this happen? First of all, because all the instruments that we use to measure corneal power actually do not measure corneal power, but measure corneal curvature. So they measure a radius in millimeters and not a power in diopters. How can we get the power? Usually in virgin unoperated eyes, we use the keratometric index, which is in most cases 1.375, to convert the radius of curvature of the anterior corneal surface into the power of the whole cornea. So it was developed probably in the 19th century by Javalos, we don't know who developed this, in order to have a very simple equation so that a cornea with a 7.5 millimeter radius in the anterior surface would give a 45 diopter power. Very simple, 7.5, 45 diopters. But this index does not correspond to any refractive index. It's a fictitious number. It's very useful because from the anterior curvature you can get a kind of measurement of the power of the whole cornea, not just the anterior one. So this is an advantage, but the problem is that it's not true, and as a consequence, and it's not true because it also depends on a fixed ratio between the anterior and posterior corneal curvature. If you change this ratio with LASIK, PRK, RK, or whatever you want, the keratometric index gets invalid, no more valid. So this happens with any kind of excimer laser surgery, where you get after myopia a flattening. And a few years ago we showed that if you still want to rely on a keratometric index, you should decrease the value from 1.375, which is here, down to 1.3265, proportionally to the amount of myopia correction. This is published on the Journal of Refractive Surgery. In this way, if you change the keratometric index according to the amount of myopic correction or hyperopic correction in the other way, you still get a good number which you can use. I have described this formula and other authors very similar formulas which give similar outcomes. So how can we measure usually the corneal power after refractive surgery? There are many methods. Some of them are in the ASCRS calculator online, others are not. Some are more accurate, others less. But you have to put them on Excel to calculate. It's not as easy unless you go on the ASCRS website, which does not contain, however, the most accurate one, which is this one. The Spiker method has been known by very few people, but we have published that it is the most reliable one, because it does not depend on the amount of correction. It just depends, you just need to know the preoperative K, and there is a weight and adjustment that I did also without preoperative K. By the way, what happens after radial keratotomy? Most of us have been thinking for a long time that both corneal surface flatten the same way so that the relationship, the ratio between the anterior and posterior surface is maintained and the keratometric index is still valid. I wrote this on some books and some chapters. I was wrong, because a few years ago we got the Pentacam, okay, we are in Galilei, measurements of the anterior and posterior surface, and we found that the relationship is lost and there's a higher flattening of the posterior surface, so that there is something opposite to what happens after myopic LASIK and PRK. And there are no mathematical formulas to correct this issue. The formulas that have been developed to calculate the corneal power after radial keratotomy are very few and not very accurate. So, as I told you, I want before to explain why IOL power calculation is wrong, it can be inaccurate after refractive surgery. And this was the first issue, the keratometric index error that makes measurements no more valid. We have also two more problems, the radius error and the IOL power formula errors. The first one is quite easy. If you have a small optical zone, like can occur frequently after radial keratotomy, but also with the first PRK of the earliest 90s, you can have the measurement, especially if you use a SIMK, which is an annulus, over the refractive knee. So you don't measure the power in the center, but on the periphery, mid-periphery. And so you get a higher value, a steeper cornea with respect to the center. If you take a cornea with a large optical zone, 6 millimeters, this problem is not relevant. But if you have a small optical zone, you should take measurements closer to the center. Each corneal topographer has its own names, ACPF. So you should anyway take the measurements of the most central rings. But as I told you, we have demonstrated that if the optical zone is at least 6 millimeters, and these are the majority of eyes, fortunately, this is not relevant. Much more important is the problem of the formulas, because I think that everybody in the world uses the SRKT, HOFEQ, and Holiday 1 or Holiday 2 formulas. Somebody is using also the Hygis. The Hygis formula is not affected by this issue, but the other formulas, which everybody uses, suffer from LASIK and PRK because they predict the ELP, the position of the lens, based on the corneal curvature. So if you have a 45 cornea, the lens will sit in a position. If you have a 40 diopters, the lens will sit in another position. Of course, if you flatten artificially the cornea by LASIK, or you make it steeper, the formula will predict a different position of the IOL, a different ELP, which is not true, because the true position, the true predicted position should be the one with the original K. So this problem was highlighted by Dr. Aramberi from Spain, who proposed the double K method to overcome this issue. So you need to know the postoperative K to get the proper focus of the rays on the retina. The double K formulas are available, for example, on the ASCRS website. Otherwise, you have to put everything on Excel, which is quite complicated. You have to look at the publications, and you can do this. So these were the three problems bringing to unexpected refractions after corneal refractive surgery. Now, how can we manage the problem of the keratometric index? We should eliminate the keratometric refractive index for eyes that need the cataract surgery but had undergone LASIK or RK or PRK. And this is possible if we don't rely on a single fictitious index, which is not true and considers the cornea as a thin lens, but we should move to ray tracing and consider each part of the system: the air, the anterior surface of the cornea, the stroma, the posterior surface, and the aqueous, and use for each diopter the right refractive index. This is done by ray tracing using Snell's law, and this is what the Galilei did a few years ago as the first Scheimpflug camera. Then other rotating Scheimpflug cameras have followed this approach because they understood that this is the right way to make calculations after refractive surgery. So you use the correct refractive indexes for each diopter, and you get the measurement of the cornea, which is usually lower with respect to what you are used to get with a SIMK or manual keratometry. So the total corneal power by the Galilei is usually 0.5, 0.7 diopters lower even in the normal eyes, unoperated eyes. You get this measurement from the G4 or the G6 Galilei, and you can enter these numbers into the IOL power formulas. But before entering them in post-LASIK eyes, we have to ask ourselves how accurate these numbers are in normal eyes, because we have been using the keratometry and simulated keratometry for many, many years. So does ray tracing numbers fit well to normal eyes? We did this study in 2011, and the answer was yes. We enrolled 43 eyes of 43 patients who got a 3-piece Acrisof, and we refracted them after 1 month. It was a very normal sample with no very long and not very short eyes. The IOL power was calculated by Hofer-Q the 1 SRKT formulas, and we calculated the mean absolute error as the difference between what we predicted, the refraction we predicted, and the refraction we observed, using the absolute error. Otherwise, a -5 and a -5 and a +5 would give you 0, and it seems a perfect formula while it is not. First issue, before going to the results, you have to optimize the constants when you choose to use the total corneal power. Since it's lower than the SIMK, the optimized constants are obviously different. And you see here, for example, using the SIMK and the total corneal power by the Galilei, you have a 0.3 difference for the SRKT. Even more if you use, this was another topographer that we used at that time for that study as a benchmark for comparison, and you see even lower. So first of all, if you have a Galilei and you wish to use the total corneal power for post-LASIK eyes, you should first optimize the constant in a sample of 30, 40 eyes unoperated, so that you know that for that kind of lens of IOL, the constant is this one for SRKT, this one for the Holiday one, and this one for the Hofer-Q. because the numbers are different. You see that with respect to the Galilei SIMK, we got a 0.4 diopter average lower value. So you have to take this in consideration. And these were the results in normal unoperated eyes as the mean absolute error. Okay, the total corneal power was a little bit higher than the SIMK by both machines. But we have to understand a few things. First of all, these have been as far as I don't know if Dr. Wang agrees, but these have been the lowest mean absolute errors ever reported in the literature. Probably as a combination of good machines, and this has been the topic of a talk I gave 1 year ago, and the 3-piece accuracy, which probably gives some more accuracy than the 1-piece, another thing. Second, all the formulas, SRKT, OFFQ, and already one have been developed to enter the SIMK or manual K readings. So, okay, it's a little bit higher, but it's still a very good number, 0.27 as an average mean absolute error. Much better than the IOL Master, for just to say a very common instrument. And anyway, there was no statistical difference with respect to the other ones. So what I say, we can use the total corneal power in normal eyes at least to optimize our constants. Then once you have optimized your constant, you can enter this value in the IOL power formulas. This is just to show that just one eye with this number out of in the whole sample had a prediction error higher than 0.75, so a very good number. Just to show that the numbers, the 0.7 mean absolute error was lower, much lower than the other values reported in the literature with other instruments or technologies. So, highly accurate in normal eyes is a good promise to get very good numbers and calculation after LASIK, because you eliminate the problem of the keratometric index. You have to optimize the constants, but of course, you have, if you use it with the SRKT holiday one or OFFQ, you have to use the double K formulas, or you use the Haigis formulas, and at this time, so you have eliminated every problem in IOL power calculation. I think, yes, this is all. Thank you very much.